You sleep for 8 hours, wake up on schedule, and still feel as if your first client call is happening underwater. Your hotel room was dark. It was quiet. The temperature felt perfect, but the small monitor beside your bed climbed through the night, and the air was not exchanging as effectively as you assumed. Before you blame your willpower, buy another supplement, or decide that jet lag has ruined the day, check the room. Welcome to Nomad Life Success, episode 174. I'm Aria Reyes. Today, we're breaking down the data, systems, and biological protocols behind hotel room air quality, dissecting the exact adjustments needed to optimize your cognitive output and protect your physical infrastructure on the road. The question is simple. Could stale air be one of the bottlenecks hiding inside an otherwise comfortable room?
Carbon dioxide is produced when people exhale. In a compact room with limited fresh air exchange, the concentration can rise while you work, sleep, or take a long call. A high reading does not automatically mean the room is dangerous, and it does not prove that CO2 caused your headache or brain fog. It is better understood as a useful ventilation proxy.
That distinction matters. CO2 can tell you that the room may not be exchanging air efficiently, but it does not measure every pollutant in the room. Humidity, temperature, odors, allergens, noise, illness, dehydration, a late meal, and a 6-hour time zone shift can all affect sleep and cognition independently. One number is a clue. It is not a diagnosis.
So what should count as a useful signal? In many occupied indoor spaces, readings around 800 to 1,000 parts per million can suggest reasonably effective ventilation, depending on the room and the measurement conditions. If the reading repeatedly exceeds 1,000, investigate. If it stays above roughly 1,500 for long periods, treat that as a strong prompt to examine air exchange safely. These are practical investigation points, not universal cognitive or health cutoffs.
The exact number can vary with occupancy, outdoor air, room design, sensor placement, and calibration. A monitor beside your face may read differently from one across the room. A device hidden behind a curtain or placed directly beneath a vent may give you a distorted picture. Use a reputable monitor that measures CO2 directly, allow it to equilibrate, and treat the trend as more informative than a single dramatic peak.
Here is the mistake I want you to avoid: changing the room before you measure it. First, take a reading while you are working, then take another about 30 minutes before sleep. In the morning, record the overnight peak and the current reading. Put those values beside total sleep time, estimated sleep efficiency, wake events, resting heart rate, HRV if you track it consistently, and a brief reaction time result. Your log does not need to be elaborate. Write down the time, the CO2 value, the room temperature if available, whether the HVAC was running, whether the window was open or closed, and any obvious noise or odor. Add a headache score from 0 to 10. Note alcohol, illness, late food, unusual stress, caffeine timing, and the number of time zones crossed. Those details are not administrative clutter. They are the context that keeps you from telling the wrong story. Now, let's make the first test useful tonight. Place the monitor in the sleeping area, away from direct breath, curtains, vents, and heat-producing electronics. Measure before bed without changing your routine. If the room starts near 900 and reaches 1650 overnight, that is a meaningful ventilation signal to investigate. It still does not tell you that CO2 is the only reason you slept poorly. The next move is safe ventilation, and this is where generic advice often becomes careless. If the property permits it, airing the room before bed may lower the starting concentration without requiring you to sleep in a cold room. But do not open a window automatically. Traffic pollution, smoke, extreme humidity, weather, noise, or a security concern may make that a poor trade. Wait, back up. Airing the room is not a universal rule. It is one possible test under the right conditions. Use the property's intended HVAC settings, confirm that the system is operating normally, and ask staff about ventilation if the room remains persistently stale. Never wedge open a secured door, bypass a lock, disable a detector,
or build an improvised airflow system around an appliance. Structure first, freedom second. A protocol you can repeat safely across several hotels is more valuable than a clever trick that works once. If better airflow creates manageable noise or light, use earplugs or a sleep mask if those tools already work for you. If it creates a serious temperature, security, or pollution problem, do not force the intervention. The goal is better recovery, not a new hazard. Build the equipment around that principle. A compact CO2 monitor is the core item. Add the correct charging cable, a small power bank, and a note template you can access without rebuilding your tracking system in every destination. Include hydration support you will actually use, an eye mask or earplugs when appropriate, and enough charging redundancy that the monitor does not fail on the one night you decide to collect data. Notice what is not at the center of that kit. A complicated supplement stack. Supplements may have a place in an individual's routine, but they do not exchange stale air. Do not add a new product to compensate for an unmeasured room. Food, adequate fluids, regular movement, and a stable opportunity for sleep come first. If you take medication, have a medical condition, or are considering a new supplement, get personal guidance from a qualified clinician. This is the expensive operational mistake. Optimizing the supplement shelf while ignoring the physical environment. A traveler can spend heavily on magnesium, electrolytes, nootropics, or elaborate sleep blends, then spend 8 hours in a poorly ventilated room and wonder why recovery data remains unstable. I am not saying every supplement is useless. I am saying you should fix the physical bottlenecks first. To see whether the change matters for you, run a 2-night comparison. On the first night, keep your normal routine and measure the room. On the second, change one variable, such as safely airing the room before bed or using the property's normal ventilation setting more effectively. Keep bedtime, caffeine, alcohol, late meals, screen exposure, and workload as similar as practical. Here is an illustrative log. Night 1 shows a peak of 1,650 parts per million. 7 hours and 20 minutes of sleep, 4 wake events, a resting heart rate of 58, HRV of 42, a headache score of 5, and a reaction time of 310 milliseconds. Night 2 shows a peak of 920, 3 wake events, HRV of 48, a headache score of 2, and a reaction time of 286 milliseconds. That pattern would justify continuing the test. It would not prove that fresher air caused every improvement. Perhaps night 2 was quieter. Perhaps you had less jet lag. Perhaps the monitor was positioned differently. One pair of nights gives you directional evidence, not certainty. Repeat the comparison when your schedule allows, and look for a pattern that survives ordinary travel noise. If your overnight CO2 is high and your sleep markers are also poor, improve ventilation safely and retest. If CO2 is normal but sleep is poor, investigate light, noise, temperature, humidity, timing, illness, and jet lag. If the room and sleep data improve but your reaction time does not, look at hydration, meal timing, caffeine timing, and workload. If symptoms are severe, persistent, or unusual, stop treating this as a performance experiment and seek medical advice. And change one input at a time. This is where high performers often undermine their own data. They open the window, change the thermostat, add a supplement, move dinner earlier, remove caffeine, and start a new sleep app on the same night. Then they feel different and call it a strategy. You need an audit trail. What changed, when it changed, and what moved afterward. A normal CO2 reading also does not clear the room completely. It only suggests that ventilation may not be the leading issue under those conditions. You could still be dealing with noise, an uncomfortable temperature, dry air, an odor, an allergen, a poor mattress, illness, or circadian disruption. Data does not eliminate judgment. It tells you where to look next. So tonight, put the monitor in the room where you sleep. Record the working room value, the pre-sleep value, the overnight peak, and the morning value. Log sleep duration, wake events, resting heart rate, HRV if available, headache score, and a short reaction time test. Make one safe adjustment, not 6, and let the pattern earn your attention.
A hotel room is not just where you sleep. For a remote founder or high-output professional, it is a temporary operating facility. Air quality is one environmental input you can measure immediately, investigate responsibly, and connect to your own performance data. Treat CO2 as a ventilation signal, not a diagnosis. Compare nights, control the obvious confounders, and fix the physical bottlenecks first. That is your high-performance blueprint for today. Remember, treat your biology like your business infrastructure. If your physical stack fails, the business stops. Minimize the friction and stay optimized. Measure tonight's room before bed and again in the morning. Then build your portable foundation at shop.nomadlifesuccess.com. The better system is the one you can carry, test, and repeat wherever the work takes you.